So, an introduction to angular motion. So angular motion is defined as the movement of a body or part of a body in a circular path about an axis of rotation. Throughout this presentation, we're going to discuss lever systems, planes of movement, axis of rotation, centre of mass, and some sporting examples. So the sports that each topic will be applied to are high jump, gymnastics, martial arts, and tennis. So lever systems, what are they? So they are rigid rods, usually a length of bone, that turns about a pivot, usually a joint. They are made up of three key components, which is the effort, the load, and the fulcrum. The positioning of these components relate to what class of lever they are. The three classes of lever are first class, second class, and third class. So a first class lever system, the fulcrum is in the middle, represented by the triangle. The effort and the load are either side, represented by the arrow and the square. In this diagram here, which is the neck, the skull is moved by the neck muscles and the fulcrum is near the jaw. The second class lever system is the load is in the middle, represented by a square. The fulcrum and effort are either side. Also, they're always going to be represented by a triangle or an arrow. An example of this would be in the lower legs. So in the calf muscles, they are going to, they're going to contract to bring the legs upwards. And then a third class lever system, the effort is in the middle, the fulcrum at the other end, and then the load at the other end. An example of that would be a bicep curl. You can see the fulcrum being the elbow joint, the effort being represented by the bicep, and then the load is the forearm and the weight that's in the hand. So planes of movement, what are they? They are imaginary flat surfaces that divide the body into different sections. They can be used to describe the direction of movements. The three planes are the frontal, sagittal, and transverse planes. The frontal plane splits the body into anterior and posterior, or front and back. Movement that occurs in this plane is abduction and adduction. The sagittal plane of movement splits the body into left and right segments. Movement that occurs in this plane is flexion and extension. I've just gone back. Yes. Yeah. The transverse plane splits the body into top and bottom, or superior and inferior. The movement occurs in this plane is rotation. So the axes of rotation are the fixed points around which rotation occurs. The three axes of rotation are sagittal, frontal, and vertical. The sagittal axis runs through the hips of someone from left to right. An example of the rotation occurring around this axis is a backflip. The frontal axis runs through the abdomen of someone from front to back. An example of this would be a cartwheel. And then the vertical axis runs through the centre of someone from their head to their feet. An example would be a pirouette. So centre of mass, also referred to as centre of gravity, is the point at which an object's mass is equally distributed in all directions. All mass is balanced at this point, and the object will not fall if balanced on another object. In the body, this point is usually found around the hips when stood in the anatomical position, or the lower abdomen when they are stood still. However, it can change as the body begins to move. So when the centre of mass moves in the body, for example in the front of the body, when the body will move in that direction, due to gravity the body will be pulled downwards in the direction of the centre of mass. To prevent us from face planting, our legs will move forwards and contact the ground, helping us to keep moving forwards. Moving body parts will also change the centre of mass. For example, during a handstand, the centre of mass will move forwards or backwards depending on where the gymnast's legs are. On to some sporting examples. So we're going to look at tennis, high jump, martial arts and gymnastics. In each example we'll look at the levers, plane of movement, axis of rotation, centre of mass and how these change throughout the sport. So for the tennis serve, there are three key movements. So a forward swing, a backhand swing and an overhead serve. What we're looking at here is an overhead serve. During the overhead serve, the body centre of mass retreats behind the head before being moved rapidly in front of the body as the player strikes the ball with their racket. This is conducted in the sagittal plane of movement because it's flexion extension. The lever system is a third class lever utilising the shoulder joint as the fulcrum, the muscles in the arm and torso to generate the effort created to create the force necessary to swing the racket and hit the ball, both being the load. So during the forehand swing, the body's centre of mass retreats behind the torso, offset to the dominant side of the player, before being moved rapidly in front of the body as the player strikes the ball with their racket. This is conducted in the transverse plane of movement because it's rotation. The lever system involved is third class, utilising the elbow as the fulcrum, the muscles in the arm to generate effort, and the load is the racket and the ball. And then the rotational axis is vertical because they are also similar movement to a pirouette. They're bringing the racket from behind to in front. And then during a backhand swing, the body's centre of mass begins to the non-dominant side before being moved rapidly in front of the body to the more dominant side as the player strikes the ball with their racket. This is conducted in the frontal plane of movement. The lever system involved is also third class, utilising the elbow joint again, the muscles in the arm, and create the force to move the load, the ball and the racket again. Instead of this time it being back to front, it's front to back. So the rotational axis will also be the vertical axis because it's literally the same as the forehand swing, just backwards. In high jump, there are three key movements, so the run up, the jump and the flop, where they jump over the bar and So during the run up, the centre of mass is continually in front of and to the left or right of the jumpers, depending from their approach position. This is due to their angled body position, leaning to the left or right and forwards to gain the angular momentum required to clear the bar. The lever systems involved are third class, where the knee and hip joint are the fulcrums, the abdominal muscles and quadriceps generating the effort force required to move the body, and the rest of the body being the load. This all occurs in the sagittal and frontal planes, with a slight sideways and forward lean causing this. The axis of rotation are vertical, sagittal and frontal, so all three. This because the rotation due to the left or right, the sagittal due to the forwards lean and the frontal due to the sideways lean during the run up. Go back. Then during the jump phase, the centre of mass is moved above the jumper, allowing them to lift off the ground. This is due to their lower body moving upwards to gain the vertical momentum required to clear the bar. The lever systems involved during this run-up are second class, where the toe joint is the fulcrum, the gastrocnemius muscles or the calf muscles are generating the effort force required to move the body, and the rest of the body being the load. The plane of movement is sagittal because of the forward and vertical movement of the body throughout this phase, and the axis of rotation is sagittal. It's because the rotation of the toe joint forwards leading, resulting in vertical movement. And then during the flop, the centre of mass is behind and below the jumper. This is due to their arching body position, which you can see here, and that's required to clear the bar. This technique, known as the Fosbury flop, is commonly used in the sport. It uses the body's momentum to rotate itself over the bar at the highest possible height. The lever system involved during this flop is first class, where the hip joint is the fulcrum, the back muscles generating the effort force required to cause this arching movement, and the rest of the body still being the load. The plane of movement is sagittal, with the backwards rotation causing this, and then the axis of rotation is also sagittal because of the backflip-like movement occurring during the flop. So onto gymnastics. So in gymnastics there are three sort of general positions and movements used in a routine. These are a handstand, cartwheel and rings. So during the handstand, the centre of mass is positioned by the position of the athlete's legs. The centre of mass remains near to the hips. However, if the legs flex at the hip or the knee, centre of mass may change. So if she were to bring that leg backwards, she'd fall over. The lever systems are third class, where the hands are the fulcrum, supporting her entire body weight. The abdominal muscles generating the effort to maintain the body's position, and the rest of the body still being the load. Planes of movement for this are both sagittal and frontal, with the flexion or extension of the joints maintaining the centre of mass over the hands to maintain stability, and dorsiflexion of the ankles to point the toes upwards, and the adduction of moving the fingers close together. And then the axis of rotation would be sagittal. This is because the body rotates around the wrist, which is like a hinge, with the axis running through them from left to right. So during the cartwheel, the centre of mass is positioned in the centre of the body, like during the handstand, and then moves as the athlete rotates. The centre of mass remains near to the hips. However, if the legs adduct or abduct at the hip, the centre of mass may change. Lever systems involved during the cartwheel are first class. In a cartwheel, the hands are the fulcrum, the body is the load, and the muscles in the back and legs provide effort to rotate the body. The plane of movement for this is frontal, with the body moving sideways through this plane around an imaginary fixed point. So the imaginary fixed point would be roughly here. And then the axis of rotation would be frontal, because the body rotates around that imaginary fixed points in the athlete's abdomen, with the axis running through them from front to back. Then during the rings routine, the centre of mass is positioned by the legs. Like during the handstand, and then moves as the athlete performs their routine. The centre of mass remains near to the hips. However, if the legs flex, extend or abduct or adduct at the hips, the centre of mass may change. The lever systems involved during a rings routine, especially in the displayed picture, are primarily third class. In a rings routine, the hands or shoulders are the fulcrum. The body, especially the legs, is the load, and the muscles in the back, arms and core provide the effort to rotate the body and hold steady positions throughout the performance. The plane of movement, particularly this part of the athlete's routine, is sagittal, with the arms and legs flexing and extending to provide more movement and stability into and out of each position. The axis of rotation for this movement is the sagittal axis. This is because the body rotates around the imaginary axle in the athlete's shoulders and wrists, and that axis runs through them from left to right. That's one. So then in karate, which is a form of martial arts, athletes perform what is known as a chop, which is where they draw power from their body and strike their opponent with their palm to cause injury when fighting, or to gain a point during a competition. The centre of mass during this manoeuvre is positioned in front of the chest, slightly forwards from the body, and moves downwards as the fighter strikes their opponent with their fist or palm, as you can see in this lovely clip. The plane of movement, the lever system is third class, with the fulcrum in the elbow, the load being the rest of the arm, and the effort being generated by muscles in the shoulder and the triceps brachii. A plane of movement that this occurs in is sagittal, as the arm is brought down as it is extended and straightened, allowing channeled force generated to strike their opponent, causing injury. Then the axis of rotation is also sagittal, as the rotation of the arm brings. The axis of the rotation is also sagittal, as the rotation of the arm to bring it from above the head to pointing at their opponent occurs around the shoulder joint, which is in the sagittal axis of rotation.